In question 7, it says, using algebra, prove that given any three consecutive whole numbers, the sum of the square of the smallest number and the square of the largest number is always 2 more than twice the square of the middle number. So before we go into detail, let's first find out what our consecutive whole numbers are going to be. So since they're consecutive and they're whole numbers, so we can assume that our first whole number is n, second whole number is n plus 1, and the third whole number is n plus 2. So these are the three consecutive whole numbers. Now the question said the sum of the square of the smallest, so n is the smallest, and the square of the largest, so n square plus n plus 2 whole square is always 2 more than twice the square of the middle number. So this is our equation, and we have to show that the left-hand side equals to the right-hand side. So let's start with expanding the left-hand side. So n square plus n plus 2 times n plus 2 equals to 2 plus 2 times n plus 1 whole square. Then n square equals to n times n plus 2 plus 2 times n plus 2 equals to 2 plus 2 times n plus 1 times n plus 1, n square plus n square plus 2n plus 2n plus 4. So now we've expanded the brackets on the left-hand side. So moving on to the right-hand side, let's expand the brackets over here. 2 plus 2 brackets n times n plus 1 plus 1 times n plus 1. 2n squared over here. We're combining the like terms on the left-hand side. Plus 4n plus 4 equals to 2 plus 2 bracket n square plus n plus n plus 1. 2n square plus 4n plus 4 equals to 2 plus 2 brackets n square plus 2n plus 1. So now if we further simplify the right-hand side, that's going to be 2 plus 2n square plus 4n plus 2. And as you can see, your left-hand side is equal to the right-hand side, which basically proves what the question was asking us to do.